hope you're all doing well. We are now in chapter 12, section 1. Elements. This section is really easy. You had it last year in grade 6. So let's start by the definition of element. The definition of element is that element is a pure substance that cannot be separated into simpler substances by physical or chemical means. This means that they are made of only one type of particle, and a substance in which there is only one type of particle is called pure substance. The particle that makes elements is called atoms. I suggest you watch this video I prepared for grade 6. It might help you understand today's lesson. And I will put the link in the description down below. Each element have a property. These properties refer to qualities or attributes that distinguish one sample of element from another. These properties are generally grouped into two categories: physical property or chemical property. The physical properties include boiling point, melting point, and density. Chemical properties include reactivity with acid. Can you tell the differences between helium and krypton based on these properties? Write your answer in the comment. So here we have a periodic table. You can see that it's divided into 3 different colors. The colors that take up most of the periodic table are green. These are the metals, and they tend to live on the left side of the periodic table. Alright, these nonmetals are on the right side of this periodic table, with the exception of hydrogen. Hydrogen ends up being a special case, and so we don't really know exactly what to do with them. So for right now, we will call them a nonmetal. Then I want you to notice that there is this stair-step line that divides the nonmetals and the metals. They are called Metalloid. So based on the periodic table, elements are divided into 3 categories: metals, nonmetals, and metalloid. Each has a different property. For example, metals are shiny. They conduct heat, energy, and electric current. Whereas nonmetals conduct heat and electricity poorly. And they are not shiny. Metalloid have properties of both metals and nonmetals. Now let's take a look and talk about that. Let's begin with the properties of metal. This is a piece of gold and has been pressed into a thin foil. That's because many metals are malleable. Malleable means that they can be formed into thin sheets. We can also talk about being able to turn metals into wire. The copper is said to be ductile. Ductile means that the metal can be formed into wires. Metals are also good conductors, and we can discuss how they are a good conductor in 2 different ways. They could be a good conductor of heat, like this frying pan here. The reason we use a frying pan is because we can heat it up with this fire, and it transfers that heat very well to whatever we might be cooking. Or they could be a good conductor of electricity, right? And we can see here that Pikachu is sticking a fork into an outlet, and he's going to get a good shock even though he is Pikachu. Metals are also shiny, right? And we might say luster as another way to describe shiny. They are almost all solid, with the exception of mercury. At room temperature, they have high boiling point, right? It's because they are those solids. Alright, metals like these lacquers are here are also hard to break. So think about that. You wouldn't want to punch these lacquers. It would hurt your hand, as metals are hard to break. We already knew that. So nonmetals are the exact opposite of metals. While most of the metals are solid, most of the nonmetals are gas. And the ones that are solid, like sulfur and carbon, they are very easy to break. Alright, so we would say that those are brittle. So the solids are brittle, and most of them are gas. They are also poor conductors, okay? We would say they are insulators. So we said most of them are gas. Look, if we use this kind of cups to help keep our coffee or hot drinks hot, notice what is in the middle of those cups. Right there, right in the area, right in here, there is just a space. There is just air there, right? And that air, which made of glass, is a good insulator. It's a pure conductor of heat. It keeps the heat in here and doesn't let it get passed through, unlike the frying pan, which pass the heat through pretty easily. Okay, and they are also not shiny. So here is some sulfur here. It's pretty dull. The ones that are solid, carbon and sulfur, for example, they're not very shiny at all. Metalloids are in between metals and nonmetals, both in characteristics and where they appear on the periodic table. So we say there are that stair step, it comes right down through here, and anything that is on that stair step is going to be a metalloid. The one exception is aluminum. So aluminum, it's on the stair to stair step, and it's appear like it will be a metalloid. Think about it. We look at an aluminum can. It is aluminum. It's a great conductor of electricity. It is malleable and it's been formed into thin sheets. And it is definitely shiny, so it's giving you all the characteristics of a metal. But all the rest of them are metalloid. Now, metalloid are going to share the properties of both metals and nonmetals. Silicon is a perfect example for this, and the very fact that you're hearing my voice and watching this video right now is because of silicon. Silicon is a semiconductor, which means that it is both a conductor of electricity and not a conductor of electricity. We can control that, and because we can control that, we can send information on off ones and zeros in a binary code. Well, this is how computers work. In this binary code, so if we didn't have semiconductors that were in your phone or in your computer, then none of this would be possible. You wouldn't have an iPhone or a Galaxy, it wouldn't happen. So you are a huge fan of semiconductors and metalloid. And that's it for today, guys. Feel free to ask any question regarding the class, and don't forget to answer the self-check questions and section review questions. Good luck. Goodbye.